Let's discuss the last problem, which is problem 8. Find I naught in the circuit using current divider. This circuit is given like this. A 3 ampere current source is giving a current, and now at this node it is being divided into two branches. One is this one and one is this one, and we want to find I naught. So to find the solution for this one, so let me discuss briefly the current divider. This is the formula for finding the current divider when you want to find the current in one branch. The current divider itself is slightly different from this formula here, but this actually tells us that the ratio of this resistor to the sum of the resistance, so this is the ratio in which the current would be divided between the two branches. So let me discuss first the statement. So so the validity for applying current divider is that all these three should be between two nodes here, and current entering should be not necessarily entering. It could be current entering or leaving this branch here. If this is coming from this direction, it can flow here and here in two branches. It can be divided into two branches. So the statement is that if I want to find the current in the R2 branch, then I have to take the opposite resistance, which is R1, and I have to divide the direct sum of these two resistors in which the current is being divided, which is R1 plus R2, and I have to multiply by the current source IS, or the current entering these two branches, and that would be the current in this branch. Similarly, if I want to find the current in this branch here, I'll take the opposite branch resistance, which is R2, divided by sum of these two multiplied by the source current. So current divider is valid only for two branches, but if there are more branches here, then you cannot use this direct statement. So now let's come to the actual problem. This is similar to the derived the formula which is derived from this circuit here. In current divider, we don't need to find the voltage across any element. We don't need that, and we can directly find the currents in the other branches, or even in one of these branches, just by current divider. So I can see that these two resistors are in series. So this branch can be reduced to a single. These two branches can be reduced to a single branch or single element, so to speak. So 1K and 1K would be 2K, but still the current would in the reduced circuit. I'll first draw the reduced circuit. The current would remain, I naught would remain the same. So that I'm going to do here now. This is the current source, 1K. Is 1K, and these two resistors, current is not being divided here, so current is same in both the resistors, so they are in series, and when we reduce the circuit in series, we can reduce one node. So 1K and 1K becomes 2K, and this is 1K. So still I naught is flowing through this path here, so that same path is reduced to this one. So this was I naught. Now it's we are good to go now to compare this one and this one. So they both are now same, so I can just directly use the formula here, which is I naught is equal to the opposite branch, which is 1K, divided by the direct sum between the two resistors in which the current is being divided, so this becomes 3K multiplied by 3, so this is 1 ampere.